Hello and welcome back to the channel. Today, we are diving into one of the most extraordinary, invisible forces in the entire cosmos, cosmic rays. These are not just random particles floating through space. They are high-energy, near-light-speed messengers that have traveled across the galaxy and even beyond to bombard our planet every single moment of every single day. You are being struck by thousands of these particles as you listen to me speak right now, and you have absolutely no idea. For decades, scientists have chased the secrets of cosmic rays, where they come from, how they gain such unimaginable energy, and how they shape everything, from our climate to the very evolution of life on Earth. This is a story of discovery, mystery, and the quiet, constant violence of the universe that surrounds us all. Let us start at the very beginning with a discovery that changed physics forever. For centuries, scientists knew there was some kind of mysterious radiation in the air, but they assumed it came from radioactive rocks in the Earth itself. In 1909, a German scientist named Theodor Wolff climbed to the top of the Eiffel Tower with a device called an electroscope, expecting radiation levels to drop sharply as he moved away from the ground. To his shock, the radiation was only slightly lower than at street level. No one could explain it. Then, in 1912, an Austrian physicist named Victor Hess changed everything. Hess was not just a scientist. He was a bold adventurer who took his experiments high into the sky aboard hydrogen-filled balloons. On August the 7th of that year, he made his seventh and most famous flight, climbing to an altitude of more than 5,300 meters, nearly 17,500 feet. He carried 3 highly sensitive electroscopes to measure ionization in the air. What he found defied every existing theory. As the balloon rose higher, radiation levels did not fall. They skyrocketed at the peak of his ascent. The radiation was nearly 3 times stronger than it was on the ground. Hess even flew during a near-total solar eclipse to rule out the sun as the source, and the radiation levels still climbed. He realized the truth. This powerful, penetrating radiation was not coming from below. It was crashing down from the depths of space. He had discovered cosmic rays, a finding that would win him the Nobel Prize in Physics in 1936 and open a completely new window into the universe. So, what exactly are cosmic rays? Let us keep it simple but awe-inspiring. They are high-energy particles, mostly bare atomic nuclei, that have been stripped of their electrons, traveling through space at velocities approaching the speed of light. Roughly 89% of all cosmic rays are single protons, the nuclei of hydrogen atoms, the most abundant element in the cosmos. Another 10% are helium nuclei, also known as alpha particles. The remaining 1% is made up of heavier nuclei, from carbon and oxygen all the way to iron and even uranium, plus a tiny fraction of electrons, positrons, and ultra-high energy neutrinos. These are not slow-moving specks. Some cosmic rays carry energies so extreme that they dwarf anything we can create here on Earth. The Large Hadron Collider at CERN, the most powerful particle accelerator ever built, can reach energies of about 13 trillion electron volts. Some cosmic rays clock in at more than 100 billion trillion electron volts, millions of times stronger. That is, the energy of a fast-moving baseball packed into a single subatomic particle. It is a level of power that defies common sense and challenges our most fundamental laws of physics. Now, the biggest question of all, where do these cosmic powerhouses come from? For years, this was one of the greatest unsolved mysteries in astronomy. Today, we have a much clearer picture, split into 3 main categories. First, we have solar cosmic rays, which come from our own sunday. These are mostly protons, released during solar flares, coronal mass ejections, and intense storms on the sun's surface. They are powerful, but relatively low energy compared to others, and the sun's own magnetic field often keeps them in check. Second, and by far the most common, are galactic cosmic rays. These originate from within our Milky Way galaxy, and scientists now know that the vast majority are born in the aftermath of supernova explosions, the violent deaths of massive stars. When a star, 10 to 20 times the mass of our Sun, runs out of fuel, it collapses in a cataclysmic blast that sends shockwaves tearing through space at millions of miles per hour. These shockwaves act like cosmic particle accelerators, slamming protons and nuclei into interstellar gas and boosting them to nearly light speed. The Crab Nebula, the remnant of a supernova observed by Chinese astronomers in 1054 AD, is one of the most famous sources of these accelerated particles. Third, we have ultra-high energy cosmic rays, the rarest and most mysterious of all. These come from far beyond our galaxy. From some of the most extreme objects in the universe, supermassive black hole jets, at the hearts of active galaxies, gamma-ray bursts from the collapse of massive stars, and even massive galaxy clusters, where colossal shocks accelerate particles to unimaginable energies. To this day, we still do not have a complete map of every source, and every new detection brings us closer to understanding the universe's most violent engines. You might be wondering, if these particles are so powerful, why are we not all constantly harmed or even destroyed? The answer lies in Earth's incredible, invisible defense system, a double shield that protects all life on our planet. The first layer is our magnetosphere, the magnetic field generated by the churning molten iron in Earth's core. This magnetic bubble stretches tens of thousands of miles into space, and it acts like a giant force field. Most charged cosmic rays are deflected or trapped in the Van Allen radiation belts, never even reaching our atmosphere. The few that make it past the magnetic field hit our second shield, the atmosphere. At an altitude of about 30 miles, primary cosmic rays slam into nitrogen and oxygen atoms in the upper atmosphere, triggering a chain reaction called an air shower. The initial collision breaks apart atomic nuclei and creates a cascade of secondary particles, pions, muons, neutrons, and more. Most of these secondary particles are absorbed or decay long before they reach the ground. Only a small fraction, mostly muons, make it all the way to the surface. These muons pass through our bodies, buildings, and even deep underground, but they are so tiny and weakly interacting that they cause no immediate harm. This dual shield is one of the many reasons Earth is such a rare and precious haven for life in a harsh universe. But cosmic rays are not just a passive threat. They shape our world in ways we are only beginning to understand. For one thing, they are part of the story behind the auroras, the stunning northern and southern lights that dance across polar skies. When solar, cosmic rays, and charged particles interact with our magnetic field and upper atmosphere, they excite oxygen and nitrogen atoms, releasing the beautiful green, blue, and red light we see. Cosmic rays also influence our climate. Experiments like CERN's Cloud Project have shown that cosmic ray ionization can help seed cloud formation, potentially affecting cloud cover and global temperatures over long periods. They also impact technology. High energy, cosmic rays can interfere with satellite electronics, disrupt computer systems, and even cause rare glitches in aircraft avionics at high altitudes. For astronauts, cosmic rays are one of the greatest dangers of deep space travel. Beyond the protection of Earth's magnetosphere, astronauts are exposed to much higher levels of radiation, which can damage DNA, increase cancer risk, and harm vital organs. NASA and space agencies around the world are constantly developing new shielding materials and strategies to keep astronauts safe on missions to the Moon, Mars, and beyond. Cosmic rays are also invaluable scientific tools. They are messengers from the edge of the cosmos, carrying information about distant stars, black holes, and galaxies that light and other electromagnetic waves cannot provide. Because they are charged, they twist and turn through galactic magnetic fields, erasing their exact path, but their energy, composition, and abundance tell us about the environments they came from. Instruments like the Alpha Magnetic Spectrometer, AMS-2, mounted on the International Space Station, have been collecting cosmic ray data for more than a decade, detecting antimatter particles, measuring rare heavy nuclei, and searching for clues about dark matter. Ground-based observatories like the Pierre Auger Observatory in Argentina scan the skies for ultra-high-energy cosmic ray air showers, helping us pinpoint their extragalactic sources. Every detection is a piece of a puzzle that connects us to the most extreme events in the universe. Cosmic rays have even played a role in the evolution of life on Earth. The small amount of radiation that reaches the surface can cause subtle genetic mutations in living organisms, driving natural selection and biodiversity over millions of years. Without this quiet, constant cosmic influence, life as we know it might look very different or might not exist at all. As we look to the future, cosmic rays remain one of the most exciting frontiers in space science. The James Webb Space Telescope, with its unprecedented sensitivity, is helping us study supernova remnants and distant active galaxies to map cosmic ray sources with greater precision than ever before. New balloon-borne experiments and next-generation satellite detectors will soon unlock more secrets about how these particles are accelerated, how they travel across the universe, and what they can teach us about fundamental physics. We are no longer just passive observers of this cosmic bombardment. We are active explorers, decoding the messages carried by particles that have traveled millions or even billions of light years to reach us. The universe is full of invisible wonders, and cosmic rays are among the most profound. They remind us that we are not separate from the cosmos, we are deeply connected to it. Every moment, particles from exploded stars, black hole jets, and distant galaxies pass through your body, linking you to the birth, death, and transformation of stars across the galaxy. This is the quiet magic of cosmic rays. They are both a violent force of nature and a gentle bridge between Earth and the infinite stars. Studying them is not just about understanding particles, it is about understanding our place in the vast, awe-inspiring universe we call home. Please like, comment, share, and subscribe to the channel.